Hello everyone. So the next type of bridge here is, we have already studied about the cable stayed bridge in the previous problem. Next type is a suspension cable bridge. So a suspension cable having support at the same level has a span of 30 meter and maximum dip is 3 meter. The cable is loaded with UDL of 10 kilonewton per meter throughout its length, and a concentrated load of 30 kilonewton 90 kilonewton is acting at the mid third points. Mid-third points as shown in the figure. So find the maximum tension in the cable. So they've asked us to find tension in the cable. So tension in the cable is nothing but the resultant. So resultant is nothing but RA, which is nothing but HA and VA, and RB is nothing but again same HB and VB. Okay. So again they wouldn't have given you only the question at times. So it's A and B is a cable state. It's a suspension cable. So you draw the cable like this and show the loading. So, and there is a UDL. In addition to this, there are 2-point loads which are acting in the mid third. So mid third means, so the here this mid thirds. Okay, so 30 meters. So at every 10 meters. So first 10 meter there's 90 kilonewton. Next 10 meter there is 30 kilonewton. Okay, these are the 2-point loads in addition to the UDL. Okay, and then. There is a 30 kilo. Show the point loads like this at this point, and then the UDL like this at 10 kilonewton per meter. Okay, first, as usual, summation H is equal to 0, summation V is equal to 0, then moment about A is equal to 0, moment about C is equal to 0. So 4 unknowns. You have to find RA, that is HA, VA, HB, VB. So to find out the 4 reactions, you need 4 equations. Okay. So first one, HA, that is horizontal forces, sum of all the horizontal forces. Okay, you can see here. So the dip is 3 meter, and sum of all the horizontal forces HA, HB, VA, VB. Find out. So HA plus HB minus is equal to 0. Then vertical forces VA plus VB is equal to 10 into 30 plus 90 acting downward, 30 acting downward. We have to also consider the point loads. Okay, so we get VA, VB is equal to 420. Okay, next is moment about A is equal to 0. Find moment about A. So VB into 30, then 10 into 30 into 30 by 2, then plus 30, this 30 into 20 meter, because you're finding moment at A. 30 into 20, then again these are all clockwise. So 90 into 10 is equal to 0. So VB is 200, VA is 220. Okay, next, moment about C. Again, moment about C, either you can see to the left or to the right. The choice is yours. Okay, so I'll see to the left now. So to the left side, there's 1, 2, 3, and 4. 4 loads acting. So to the left side, moment at C to the left is equal to 0. That is 220 into 15, exactly half, 15. So it's clockwise. So it is 220 into 15. Next, HA. Okay, so HA is now, again it will always travel along the length of the cable. So HA is now going anti-clockwise. So HA into 3. Next, minus 10 into 15 into 15 by 2. So it is 10 into 15 square divided by 2. Next, again 90 is going in anti-clockwise. So it is minus 90 into this distance. Okay, that is exactly half. So complete distance, this is 10 and half of this is 5. 90 to 5 is equal to 0. So now find out HA and HB. Okay, solve this equation. So obviously we'll get HA and HB is just the opposite. Okay, same. HA, put it back in the equation here. Okay, so you'll get HA and HB. Next you have to find, you found out VA, VB, HA and HB. So find the resultant. So we know that resultant RA is square root of HA square plus VA square, and RB is also HB square plus CB square. Okay, so find out this. Now you can see a maximum tension. Always, whichever reaction will have maximum value, that is the maximum tension. Minimum tension is this, less value. So maximum tension is 615 and minimum tension is 608. Then you have to find the length of the cable. So this length of the cable, okay, extra complete length of this cable is, again you have to use the same equation, that is L plus 8h square divided by 3L. So L we already know 30, then 8h square, h is 3 square divided by 3 into 30. So LC is 30.8 cm. The meaning of this is the clear length is 30, but the cable length is 30.8, that is 0.8 meter is extra. Okay, so these are the only types of problems you'll get in exam. So you have to only find maximum tension, minimum tension, and length of the cable in this cables. Okay, so only thing you have to know here is when you're drawing this cable, be careful with the length and the depth and draw this loads properly. And it is only 4 equations you have to use, that is summation H is equal to 0, summation V is equal to 0, moment about A is equal to 0, moment about C is equal to 0. So you'll get the reactions. Okay, on the same lines. All right, now see here in this problem, what they've given is now the supports are at different level. Okay, now see here, a cable of span 100 meter has its ends at a height of 8 meter and 15 meter above the lowest point. So lowest point is obviously C, center. So from the lowest point, one support is at 8 meter, you can see 8 meter. The other support is at 15 meter. It's actually from this portion C. It is 15 meter. Okay, and from the lowest point of the cable, it carries a UDL of 10 kilonewton per meter. It carries a UDL of 10 kilonewton per meter. I cannot draw the UDL above here, right? So I've shown it here, this portion like this. And determine the horizontal and vertical reaction at the support. What is the length of the cable? Now see here, they are C is the lowest point and support A is at a lower level, support B is at a higher level. So with respect to C, it is at 8 meter. With respect to B, it is 15 meter. Okay, now let us find out the length first. This L1 between AC and BC will find, because it is at a different level. The same concept we had used for arches also. Okay, same formula, the same concept. So we know that here L1 divided by A1. Okay, so this is 8 meter, square root of 8. So L1 divided by square root of 8, L2 divided by square root of 15 is equal to total length. How much is the total length here? L1 plus L2 is 100 meter. So L1 plus L2 is 100 meter. Then add both the A1 and A2. So it is square root of 8 plus square root of 15. So now L1 is equal to, take this, okay, 100 divided by, see it's like L1 by root 8, so root 8 will go this side. So 100 divided by root 8, then root 8 plus root 15. Solve this, you'll get L1. So L1 is 42.2. Similarly, find L2. So again, L2, what you can do is, say again same thing. When you add both of this, you can either do this 42.2. Once you get this, what you can do is 100 minus 42.2 will get this. 100 minus 42.2 is 57.8. Okay. Now again, as usual, summation H is equal to 0, summation V is equal to 0, moment about A is equal to 0, moment about C is equal to 0. Okay. So first, summation H. So it is, okay, now see here, the loading is like this. We've shown it below, but obviously it will be acting above here. I cannot show it here, so I'm showing it here. But the loading is acting like this in opposite direction. Okay, so now what I'll do, loading is acting upward. So reaction will be acting downward. You can see here, I'm showing the reaction acting downward. Loading. It's just that with respect to the loading, the reaction should be acting opposite. To stop that external loading, reaction should be acting just the opposite. So here I've shown, you can see the arrow here, it is acting like this, upward. So because it is acting upward, reaction, this VA and VB is acting downward. Alright, so now HA and HB, again HA and HB, I'm going to show it as they acting HA is acting to the right, HB is acting to the left. So HA plus minus HB is equal to 0. Then summation V, VA plus VB is equal to 10 into 100. That is 1000. Then moment about A. Find moment about A. Now see here how to find this moment about A is HB into this distance. See here, this is 8. Complete height is 15. Okay, so 15 minus 8 is this distance. Okay, complete height is 15. From C it is at, from the distance between C and A is 8. But what we want is this distance, A and B. Okay, so 15 minus 8 will give me A and B. Okay, so HB is now, it is like this, HB into, it is going anti-clockwise, so minus HB into 7. Okay, then VB is going like this, clockwise, so VB into total distance, that is 100. Then this UDL, now it is going to reach A. Okay, it is going anti-clockwise, so it is now 10 into 100 into 100 by 2. 10 into 100 into 100 by 2. Okay, solve this. Okay, still both are unknowns only. Okay, both are unknowns. We'll keep it as it is, this equation. Then we find moment about C. So moment about C. So what I'll do here is I'll consider only the left portion. Here. Okay, first if I consider the left portion, moment about C, only this side, left side. HA, VA, only I'll take these two. Okay, why I'm taking these two is because I want to express one in terms of other. So you can see this diagram. I'll take only between A and C. I'm not considering, as of now, I'm not considering this external loads here. Only I'll cut the section here, AC, only left side forces, right side forces. Okay, see here, HA into perpendicular distance. Now this is going like this. It has to reach C. HA into perpendicular distance is clockwise. So it is HA into this height, 8. Then VA. Now see here, VA. This is also going anti-clockwise. See here, HA is going clockwise like this. So HA into 8. It has to reach C. Okay, then VA is going anti-clockwise. So VA into this distance. That is 42.2 is equal to 0. So express one in terms of other. So you can see here HA in terms of VA. Okay, we want to solve this. Again, it is still unknown. So what we'll do? We'll again use this MC now. This left side is over. Now when I'm finding moment at C, then I will consider all the loads. So when I'm finding moment at C, this is the longer span. I will consider HB, VB. In addition to this, I consider the UDL. Okay, so only in BC span. So it is VB is going in anti-clockwise. Okay, you can see here VB, it has to reach C. Force into perpendicular distance. Okay, so this is right side clockwise negative. So it's going clockwise. So VB into perpendicular distance. So minus VB into perpendicular distance. Then plus HB into its perpendicular distance. So this is going, this is also going along the length. Okay, so HB into 15. Then this is again 10, which is going clockwise, right side clockwise negative. So 10 into 57.8 into 57.8 divided by 2 is equal to 0. Okay, so solve this equation. So we'll be considering only the horizontal forces here. Okay, so we tried solving. Again here, VB is also unknown, HB is also unknown. Still we cannot find this. So what we'll do here is we'll take the bending moment at the mid section only. So I'll treat this as H, only one force. H into 8, okay, H into 8, then minus 10. Okay, I'm not considering the vertical forces. I'll consider only horizontal force and the external load. Horizontal force, external load. Okay, now this pattern should be followed for the supports at a different levels. Okay, so horizontal force into perpendicular distance, and then 10 into, okay, so it's 10 into this distance. Okay, 10 into 42.2 square. Okay, 42.2, this only this distance is equal to 0. So we'll find h is nothing but ha is nothing but hb. So find h. Then similarly, once you find ha and hb, put it in this equation. Find vb. Once you get va and vb, ha and hb, next calculate the length of the cable. So the length of the cable is same. Okay, now because there is a difference in the height here, there will be slightly change in the formula. So length of the cable LC is equal to L plus 2/3 of H1 square by L1 plus 2/3 of H2 square by L2. So put this formula and write L 2/3. First H1 is height 8 and divided by L1, then 2/3 H2 square 15 square divided by L2. So solve this. I can see here LC is always more. So length of the cable is 103.6. So clear length is 100. Length of the cable is 103.6. Okay, this is how you solve the problem when there is a difference in the level of the support for the cables. Okay, that's all for today. Thank you.